Okay, so we're going to jump into the demonstration portion of our presentation. And once again, we have everything separated into two different areas. We have all of our federated learning code on Google Colab, and then we have our blockchain being hosted on Replit. So very quickly, we have this blockchain class where we define our private blockchain implementation, and then we create a Flask app that deploys a web app that will host our blockchain on a network. And so if we run the Replit, it's going to provide us with a link that we can use in Google Colab to get access to our blockchain. And once we have that in there, we can go ahead and go through the code. We'll start with the global model. And so once again, the global model houses the aggregate model. It houses the big model that takes all of the individual client trainings and forms them into a robust and accurate model. And so the first couple of code blocks are going to be our imports for things like PyTorch, Base64, requests, different things. And then we also import the training data. We define our hyperparameters for our CNN here. And then we're going to be doing 2 clients and 2 rounds just for demonstration purposes. We have some code for interacting with PyTorch and determining if we want to use GPU versus CPU. We have our class here for federated net, which is our model that we're going to be using to doing our training. We have our functions here for compressing and decompressing the training results so that we can transmit them over the network. And then here we start to make things happen. So we instantiate the global net. And the first thing we do is we take the parameters from the global model and we put them into the blockchain. And that's a process that happens a lot over and over because, once again, the global model has the most robust version of the training models and the gradients. So we want our local clients to be using those when they're doing their trainings. So we send this into the blockchain. We can see that a new block was forged. And we see this key here called gradients, which houses all of the parameters for the training model that is coming from the global model. And we can run this next piece of code here. And what's happening with this code is it's going to be listening for new transactions from the local clients. It's waiting for new training results to be sent in so that it can be aggregated. And so we can go ahead and send some transactions now with the local client code. A lot of this at the top is the same from before, just defining different imports and parameters and such. But once we get to here, we can see that we have this class called client. And so this is just an encapsulation of all the things that are individual to a client. So every client has its own individual data set that it's going to be training on. And then each client has a federated net model that it's training on the data. And so here we're just creating some clients so that we can create some transactions. And then running this next piece of code, what happens now is each of these clients is going to be checking if there have been any updates to the global model parameters. And now we just sent those parameters from the global model just a second ago. So these gradients here are going to be pulled in to these local clients so that they can train using the most accurate parameters, the most up-to-date parameters. And so we defined 2 clients and 2 rounds each. So these are just going to be doing some trainings. We can see the first client did its first round of training here. And we have to wait for the second client to finish. So it just finished here. But we have to wait for all of the clients to finish before the aggregation process starts. And so now both of these trainings have been done. And we can notice that the transactions were sent to the blockchain. And so now we go back to the global model. The global model was listening for those transactions and waiting for new training results to come in. And so now that they've come in, it went through the rest of this code to perform the aggregation. And after the aggregation occurred, once again, we want to update the blockchain with the most current parameters from the global model. So that's what this is here. A new transaction was sent, and that transaction is essentially updating the most accurate parameters to the blockchain. And this process repeats essentially. So we're waiting for another round to happen of training. So we just had the second round happen for the first client. If we just give it a few seconds, the second client will finish. And it's just a continuous process of communicating between the clients and the server. So we can see that these transactions were finished and sent to the blockchain with the new results from their trainings. And so the global model, once again, is going to see that new transactions were sent. There's new training results to aggregate. And so we're going to aggregate those, and then we're going to form a new block that contains the most up-to-date parameters. And this is the gist of our code. We have some more code for things like visualizations and stuff, but we'll touch up on that in the presentation. But that's it for the demonstration.